Welcome to the BMP RAM user guidance video series. Each video is designed to be 10 to 15 minutes long and provides supplemental information to the user guidance document available for download at bmpram.com. This video, entitled Determine Your BMP Type, Centralized BMPs, guides you through the concepts and decision points to determine your centralized BMP type. Another guidance video is available which addresses how to determine decentralized BMP types. A structural BMP is a physical structure that has been specifically sized to accept, attenuate, and/or treat urban stormwater runoff through some combination of detention, retention, or filtration. Structural BMPs are implemented on public and private property to improve downstream water quality by either reducing runoff volumes and/or capturing pollutants and reducing the associated concentrations. In most instances, structural BMP sizing is based on site considerations to treat regional stormwater volumes generated from the contributing urban drainage area, such as the 85th percentile 24-hour precipitation event or 20-year 1-hour storm. Common stormwater nomenclature includes dozens of individual names for structural BMPs. BMP RAM focuses and refines this naming complexity by defining structural BMP types by their physical characteristics and the combination of processes relied upon to improve downslope stormwater quality. Users of BMP RAM must identify the structural BMP types per one of the BMP RAM 14 defined types, rather than relying on previous naming conventions. We believe this nomenclature simplification and consistency improves communication and the understanding of expected water quality performance of any specific structural BMP. It also makes water quality effectiveness data collected from structural stormwater BMPs of the same type more directly comparable. In BMP RAM, each BMP type has a unique set of data inputs for each step completed by the user, including inventorying the location of a structural BMP, establishing benchmark and threshold values, and conducting a series of specific field observations to determine the condition of the structural BMP at the time of assessment. BMP RAM directly addresses the fact that a BMP's condition declines over time and periodic maintenance is required to sustain treatment effectiveness. BMP RAM assessments can be repeated year after year to cost-effectively inform appropriate maintenance schedules and document BMP improvements when maintenance is performed. In order to assess the condition and relative maintenance priority of structural BMPs, BMP RAM requires different inventory and field observation data inputs depending on the BMP type. Defining the correct BMP type is therefore essential. To get started, you must first locate the BMP. Only BMPs that have been constructed and are in the ground should be inventoried in BMP RAM. In other words, hypothetical BMPs or potential BMP plans cannot be assessed by BMP RAM. The most accurate way to determine the BMP type is immediately following construction, because at that point the purpose and design of the BMP will be most apparent and institutional knowledge will be fresh. We realize, however, that many BMP RAM users may be inventorying older BMPs that have been in place for several years, and engineering design plans or other construction or installation specifications may be difficult to find. All BMPs should be visited in the field to confirm the BMP type. Do not rely solely on design reports. For one, construction does not always follow design. Additionally, older BMPs may have transitioned to a different BMP type due to poor maintenance or vegetation growth. Once the BMP type is identified, design parameter and benchmark and threshold values are entered into the tool based on the BMP type. These data can be collected while on site, and the details for data collection and entry are provided in the user guidance, chapters 3 and 4. In the case of older BMPs, maintenance may be required prior to completing the benchmark and threshold step. BMP RAM groups BMP types into two categories, centralized and decentralized BMPs. And determining the BMP type of any structural BMP is a critical first step of the BMP RAM user. Centralized BMPs are typically larger and designed to treat stormwater generated from drainages that may be many acres in size and include a mixture of urban land use types. Decentralized BMPs are commonly designed and installed to reduce runoff from smaller drainage area of a single land use type, such as a commercial parking lot or a multifamily residential roof. The remainder of this video guides you, the BMP RAM user, on how to determine BMP type of centralized BMPs. Second Nature has an additional video which systematically defines how to determine your decentralized BMP type. Centralized BMPs are typically larger in size, treat a larger urban drainage area, and are more costly to design and construct than decentralized structural BMPs. BMP RAM defines 7 centralized BMP types based on their common features and the fundamental processes they rely upon to improve water quality. The 7 types listed here are dry basins, infiltration basins, media filters, bed filters, wet basins, treatment vaults, and detention basins. As you can see, we have also provided examples of other common BMP names for each of these 7 centralized BMP types. We use the flow chart on page 19 of the user guidance to walk you through the key decision points when determining your centralized BMP type. The first question that we have to ask when categorizing a BMP is if it is moderate to large in size and/or if it accepts runoff from mixed land use drainage areas. If the answer to this question is no, the BMP is most likely a decentralized BMP, and there's a separate user guidance video and classification flowchart that addresses those. If the answer to this question is yes, it qualifies as a centralized BMP, and you're watching the right guidance video. We next need to know if the BMP provides stormwater volume reductions via infiltration to the subsurface and associated pollutant load reductions via retention in the subsurface. For example, is the base of the BMP native soil, or has it been excavated and replaced with highly permeable media such as gravel or cobbles? To promote infiltration. Note here that BMPs designed with an underdrain to capture the stormwater after it has traveled through this media do not infiltrate and are addressed in another part of this flowchart. If this is an infiltrating BMP, then we want to know if it ponds stormwater to encourage particle settling. In other words, has it been designed to detain or attenuate flows, to reduce velocities and allow for particulate settling prior to the stormwater exiting the outlet? BMPs that infiltrate stormwater and encourage particle settling by way of ponding are classified as dry basins. Dry basins are flow-through basins that are designed to capture and pond stormwater, yet completely drain between storm events. Stormwater volumes are reduced via infiltration to the subsurface, and pollutant concentrations in stormwater are reduced by particle settling and capture as a result of the detention of volumes and reduced flow velocities. Dry basins have treatment orifices at the outlet that are engineered to slowly drain the basin. BMPs that infiltrate stormwater but don't retain flows in a pond are classified as infiltration basins. Infiltration basins are flow-through basins with highly permeable substrate, such as aggregate or rock, and little to no surface detainment storage. There is no engineered treatment orifice, only a bypass outlet, and vegetation is minimal and preferably absent to prevent the relatively high infiltration rates. To preserve relatively high infiltration rates, pardon me. Two schematics here illustrate the functionality and difference of these two centralized BMPs. Both accept runoff volume and reduce it by way of infiltration to the ground. Both have a designed treatment capacity and a bypass outlet if that capacity is overrun. The dry basin has an engineered orifice that controls the outflow rate of water prior to exiting through the outlet, allowing water to temporarily pond and particles to settle. Infiltration basins do not have this engineered outflow. These schematics also identify the required design characteristics that define the sizing and hydraulics of the specific BMP. These parameters must be entered into BMP RAM in order to assess and track the effectiveness of the BMP to reduce the water quality impacts of urban runoff. Similar schematics will be shown for the other centralized BMPs discussed in this guidance. For BMPs that do not infiltrate stormwater to the subsurface, we want to know if the BMP is an engineered flow-through system containing media filters. Media filters reduce pollutant concentrations by physically trapping, separating, or sieving particulate matter and using active media to treat dissolved constituents. Note here that media filters are different than treatment vaults, which we will discuss in a few minutes. Media filters have filter units that may capture particulate pollutants and/or treat dissolved constituents, whereas treatment vaults physically separate particulate pollutants via other water separation and settling techniques. The stormwater is filtered via proprietary flow-through filter systems such as a storm filter, perk filter, or jellyfish, to name a few. The BMP is classified as a media filter. Media filters are typically installed in underground vaults, are accessed via manholes, and are comprised of filter units filled with compost, perlite, carbon, or some other compound. No stormwater reductions occur with these BMPs. If stormwater filtration is not via a proprietary filter unit, for instance if it's just through a medium of sand or gravel, then the BMP is classified as a bed filter. Bed filters are typically installed subsurface and use gravity to filter stormwater through a sand or gravel media. All volumes are captured in an underdrain and carried downslope, so no volume reductions occur. If no media filtration takes place within the BMP, the next question is if it retains stormwater in a persistent pool and possesses standing and healthy vegetation that can tolerate periods of longer inundation. These BMPs are classified as wet basins. Wet basins are flow-through basins designed to retain some volume of stormwater runoff in a persistent pool of surface water. Designs may include additional detainment storage of stormwater for some minimum time to reduce peak flows. Dense vegetation of wetland and riparian species is common, encouraging biogeochemical cycling of pollutants, and the basin substrate is typically fine organic matter and silt. The final question in the flowchart for classifying centralized BMPs asks if the BMP is a closed system and if it physically separates particulate pollutants by way of separation or settling techniques. BMPs that do not qualify under this question of physical particle separation or under the other questions we've been through regarding volume infiltration, particle filtration, and persistent ponding are most likely detention basins. Detention basins are flow-through basins designed to detain stormwater runoff for some minimum time in order to reduce peak flows. They are designed to completely drain between storm events, but little to no volume loss occurs via infiltration due to an impervious or highly impermeable base. Depending on design of flow paths and drawdown times, particle capture via settling may occur. Finally, closed system BMPs employing physical particle separation are called treatment vaults. Treatment vaults are proprietary, prefabricated subsurface flow-through structures that physically separate sediment, trash, leaf litter, and other particulates through separation and settling techniques such as swirling vortex, screens, baffles, and weirs. When functioning properly, pollutant concentrations should be reduced, but no stormwater volume reductions occur. Note here that hydrodynamic separators or other BMPs that we classify as treatment vaults can come in many sizes, including small units that can be placed in drop inlets that only drain 100 square feet of roadway. This variability in treatment vault sizing will also be addressed in the guidance video on determining decentralized BMP types. Again, this flowchart can be found on page 19 of the BMP RAM user guidance, accessible for download from the BMP RAM website. Now, there are several instances where a user may have trouble distinguishing between two different BMP types. Following, we provide some guidance to differentiate between commonly confused BMPs. First are dry basins and detention basins. Both of these BMPs are basins and are expected to drain completely between storm events. A detention basin is not designed to infiltrate stormwater volumes and likely has shorter flow paths and drawdown times than dry basins. Dry basin is designed with a permeable surface to promote infiltration and has longer drawdown times and flow paths to promote particle settling. Dry basins and infiltration basins. As discussed earlier, both of these BMPs are expected to drain completely between storm events, have permeable surfaces to infiltrate stormwater volumes to the subsurface, and have bypass outlets in case the treatment capacity volume is exceeded. Dry basins temporarily pond water to promote particle settling and have an engineered orifice that controls the outflow rate of treated water prior to exiting through the outlet. Infiltration basins only have a bypass outlet. media filters, and treatment vaults. Both of these BMPs are proprietary, prefabricated subsurface vault structures that reduce pollutant concentrations but not stormwater volumes. Media filters have filter units that may capture particulate pollutants and/or treat dissolved constituents. Treatment vaults physically separate particulate pollutants such as trash, sediment, and debris via water separation and settling techniques like swirling vortex, screens, baffles, and weirs. Lastly, media filters and filter beds. Again, as discussed earlier, both of these BMPs are subsurface structures that reduce pollutant concentrations but not stormwater volumes. Media filters are typically located in an underground vault and use proprietary filter units filled with compost, perlite, or carbon, while bed filters are usually buried under the surface and use gravity to filter water through a gravel or sand substrate before collecting it in an underdrain and routing it downhill. This brings us to the end of this guidance video. Please visit bmpram.com and secondnaturellc.com for more information about BMP-RAM and our other stormwater assessment tools. BMP-RAM was originally created in 2009 and is incorporated into the Lake Tahoe Clarity Crediting Program. Recent refinements have been developed in collaboration with the Central Coast Regional Water Quality Control Board and the Low Impact Development Initiative. We are extremely appreciative of the continued public agency encouragement and support. Good luck ramming, and be sure to check out our other instructional videos.